Okay, good morning. My name is Paul Oakley. I head up the BIM team at BRE, and if you want to know millennials, you probably know what to do with that thing, so you can press a button and things will happen. Okay, so my background, to show how new this BIM thing is, that was my first BIM model. Then in AutoCAD Release 2 in the mid-80s. Okay, so this stuff isn't new. Okay, I was linking data to that even though it was AutoCAD Release 2. And things were going to happen. But it took 3.5 days to render that on the screen, and then you had to take a camera out, take a picture, and that was the technology after you took it down the dark room and printed it. So in terms of technology, the way we interface with data and stuff has globally changed over that period. I'm an architect, 20 years working as an architect, 10 years running my own consultancy, involved with a lot of the major sort of CPIC, Building Smart. I was chair of the Autodesk user group, sat on many of the BSI, so BS 1192 2007, PAS 1192 Part 2, 8541, sat on the ISO committee where it's moving to ISO. So I'm involved with a lot of the standards development on this stuff, as well as working Building Smart internationally as well. So I'm here today to talk about Lexicon, which is looking at basically creating a BIM industry standard. So the BRE, Building Research Establishment, we work in lots of different aspects within the built environment. The particular areas I look at after or in the BIM, so if you want to find stuff about what's going on in the BIM task group, the latest stuff in terms of documentation, that's in our About BIM. We provide certification for individuals and companies. We're involved with training at different levels, as well as workshops and other events for industry. We also carry out various research projects, working with universities and looking at the future possible development of BIM. And a lot of this stuff that we're talking about today comes out of those research projects and how we're trying to move things forward. So I'm just going to talk to you quickly about what BIM is. This thing called BIM Level 2 in terms of what's required as deliverables, and then the problems in actually delivering those things. And then we're getting into basically this thing about structuring BIM data. So BIM, what is it? Well, it's not just 3D CAD. It's not new technology. Okay, it's been around for a long time, and there are people out there doing it. That's the BIM task group, value creating collaboration, but really it's about this. It's about better information management. And it's key that we get better information so we can make decisions. Even the acronym has different terms. So we have BIM as in terms of information model, the thing that's produced. How we go about producing that thing also depends on our deliverables. But the key driver for the UK standards and the Level 2 mandate is this thing, information management, which is the process of the who, what and when. And that is one of the differentiators between what the UK are doing and what has been happening in other countries. We talk about the BIM model. We have the graphical model, the bit that everybody likes, the visuals, the visual data, that side of it. Associated with that is the non-graphical data. And that is particularly more important when you start to move into the FM world and operations and that. It's the non-graphical data as opposed to the visual data. But those two combine to create the documentation. And we should have those bidirectionally linked, so any changes within the graphical model or the non-graphical data should also be reflected in the documentation. So we have this thing called BIM Level 2, which is mandated by the UK government, and the normal wedgie, which really shows the path to how we're going to get there. And we have all these different silos, so an architect information model, a structure information model, etc. Different disciplines owning their own data. And they're shared through this thing called a common data environment. But this is the way that BIM can be developed to basically get over the legal, contractual, the procurement issues that we have at the moment. And sometime in the future, we'll get to this Level 3 integrated BIM, where hopefully we can resolve a lot of these issues. But the PAS 1192 Part 2, which sets out the design and construction, talks about deliverables. And the key elements are proprietary file formats created by the people authoring, PDFs to record the documentation, and then this thing called COBE, Construction Operations Building Information Exchange. Now, the last section talks about soft landings. But the whole thing about the Level 2 requirements is it's basically beginning with the end in mind. that the client and their operations facilities team that basically need to define their organisation information requirements, their asset information requirements. So they then become part of the employer's information requirements, along with plain language questions, which the supply chain then deliver the project information model, which then gets passed into the asset information. So basically, the requirements for operations and maintenance get picked up by the design teams. So it's things like room numbering that is required for operations. So those things actually are asked for at this stage here, so they actually can be put into real data. Now, when I started, it was dead easy. We were on the drawing board. We produced pieces of paper and we issued them with die lines. Then moved into a CAD scenario, but actually all we did was produce electronic drawing boards. So we produced the same drawings. And then we moved into BIM. And the problem is, for most people, it's the same thing. They're just delivering bits of paper, even though they look a bit prettier than they did before. But we now get this thing called COBE, Construction Operations Building Information Exchange, which is a requirement, which actually requires structured data. And that is a big change for designers and constructors, because previously they haven't had to deliver structured data. Whatever it said on the bit of paper, that was all they were required to deal with. So the whole way they need to think and deliver information needs to change. So COBE is this big Excel spreadsheet. So we say, call blimey, it's Excel. That's the acronym. But you've got multiple tabs there, which basically all different bits of information. Now, one of the issues with COBE is just a briefcase. And the perception is you need to put everything into that briefcase. Whereas the employer's information requirement should actually be defining what information do they need for the organisation, the asset requirements, to be delivered within this. And it's that filter that needs to happen to make sure that the COBE is appropriate to the business needs. It's all about this guy. Okay, we need to get to data. Fortunately, I was delivering in China last week and they're calling something completely different, so it's completely lost on them. But it's all about this mobile technology, linked information, user information, etc. Data. With good data, we can make good decisions. And that is key to how we're going to drive this whole thing. But the perception was, at one point, that basically this was going to resolve all the problems. The BIM object. It had our visualization, it met our graphical standards, and it had this data associated with it. And from that, we would then be able to deal with all the asset, the project requirements, because we have these BIM objects which are going to resolve all those problems. And then from that, we get into what we need to do in terms of the big data, Internet of Things, smart cities, all that sort of stuff, because we can pass information for all these different systems. But the problem we have is that we don't get good data. When I started, this was my BIM library. It was dead easy. Okay, all my graphics came out the same. I just put an arrow to specification clauses and they were standardized. And that's the way that you worked. We now get this sort of scenario. So my BIM object, okay, looks pretty, looks like a piece of furniture, but the reality is, for those who know a bit of software will realise actually that's not a piece of furniture. In fact, it's a curtain wall object. So basically, I can use the authoring tools to create all sorts of different things that look visually and can print out and produce pieces of paper, but actually the structured data that's delivered behind them is completely wrong. And that's what we'd normally look before I played with it. So we have this issue that we have data associated with objects which isn't necessarily correct. We get a scenario like this. So one of the software vendors have put these 3 walls with a half hour, 1 hour and 2 hours, but they all actually use the same plasterboard material with exactly the same properties, same performance criteria. Well, actually you couldn't get that just by increasing the size of the cavity. If you look at British Gypsum, they have a whole range of different boards which meet those performance criteria, and associated with those is different materials, etc., which define all this stuff. So to get the data that we're going to need to analyse, we need this standardised, we need this resolved. And we talk about the object standards. Now the trouble is, again, there's lots of object standards out there, they're all different. We have different graphical standards, and there's a lot of work going on both in the UK and globally trying to resolve these sorts of things. Even just basic things like a window. Okay, is it top hung or bottom hung? Well, BS 8541, it's top hung, Australian standard, bottom hung. So we have different symbology, meaning different things in different parts of the world. So therefore, understanding the locale from where the objects are created is key to understanding how things work. And then different software deals with things differently. So you might get one piece of software which has variable width objects, another which has fixed width. So how we name those becomes an issue in terms of when we're looking at data as we move into operations and maintenance. And then we get the use of things like special characters within object names, which then when we're trying to export that, again creates issues for us. So using efficient standards that get rid of these special characters allow us to exchange information. And if we get to the most basic level, what do we call the two sides of a rectangle? Okay, we don't even standardize on that. Different things, even within single pieces of software, they use different terms. So just standardizing on some of this basic information will allow us to get to that goal that we previously set in terms of exchanging requirements. And then we look at the way that particular tools do it, where you can create your own parameters or attributes, and you can spell them right, or they're case sensitive, etc. These are all issues that we need to resolve. And then we get into things like the insertion point, base point. So people talk about within the evolution that we can swap one object out for another. If they're not using standardized location points, then when you make that change, things are going to move within space. So these sorts of basic rules in terms of how we set up stuff is important. So we need to get through all of these issues and resolve these problems. But the perception was that the BIM object libraries will resolve all this, and all these people have different libraries out there, but actually the trouble is they all do things differently. So if you took a parameter for description, some of them might use uppercase or lowercase. Actually, they all have completely unique GUIDs. So therefore, if you're trying to export that information, you're going to get different points within the table. So you're going to get one of those, you're not going to get all of them. And that's a problem when you're trying to pass information from design construction into operations and maintenance. You get things like, I mentioned National BIM Library, but they're one of the good ones, and some of the others are a lot worse than those. But this is some of the data, 3, 4, 5, 6 sheets of information relating to objects. But actually, a lot of that information is irrelevant to what we need to use it for. Okay, it's right for the specification, but it doesn't deal with the operations requirements of it. And then is that information correct? Is it coordinated? Is it up to date? How we deal with all those sorts of issues. So we need to start thinking about this sort of stuff and driving this. And basically, we need to get over this risk, liability, productivity issue to make it quicker and easier for people to use the correct information. So the perception is that previously that we throw everything onto the BIM object, we create these massive big files and nobody can actually use them. But we need to move to a web-enabled linked data approach. That all of the requirements can start being tied to the object, but that also we can get to the appropriate information for those who don't need the graphical symbology, but they need the other information, the other data associated with it. And that also resolves some of the security issues about linking data. So the key thing is about the single source of the truth. And we have generally two lots of information. We have those provided from manufacturers, testing organisations, specifications, etc., and those who want it. And the problem at the moment is we're trying to jump all these hurdles and we need direct links between the two. So the BIM task group has been working on this project, and they've recognised from this that we have basically two lots of information, those that have and those that want, and somehow we need to start joining these together. So there's manufacturers, there's loads of standardised data available, okay, that is produced from them. And if we want to use that information appropriately, so something like BREEAM, we might want to test a particular project to see does it meet the sound attenuation requirements. So we then need information about the design of that. So we might be looking at standardised details, we might need to zoom into particular areas. We might need to be looking at how we can resolve this well-being issue. So to do that, we need information, we need data. So we can start looking at the components that make that up. We can start looking at the details, how these things come together, And then we can start analysing that. And does that provide the information to say, yes, this meets our requirements? So we can get down to the individual object level. We can look at how that responds to our requirements. So really we need to sort these two things out. The requirements for information, how we define those, whether they're relating to performance, to cost requirements, to management, to ongoing operations, etc. So we have this whole list of information that is required by different people within the life cycle. And it's then sorting out which of the bits that we actually need. So we need to go through and identify what they are so we can define those. And that creates what we call an information request template. And then on the other side is all the information that already exists. All the stuff manufacturers have to provide legally to meet all the European and other standards. Okay, the stuff that they produce out there to satisfy those. And then we need to map the two things together. So what we're working on is this thing in the middle. The data standard that basically brings what people have and what people want together. So basically we can pass information from those who have it to those who want it in a standardized format that everybody can use. That will then allow us that when we come to the end of projects that we can pass information from the designers and the constructors into the operators. So that's where the likes of Kobe can suddenly happen, because actually we start populating Kobe with correct information that can be linked to other things. So the project that's been working on that is something called Lexicon. Okay, BRE won the bid from the BIM task group in terms of delivery of that. So we're basically producing the tool to hold the data standard. It can be accessed from bretemplater.com. It's there. At the moment, it's just populated with test data. So different people are playing with it. But the idea is we have templates which are linked to multiple classifications for different types of objects. And the templates are generally based on IFC 4.1 schemas, you know what that is. And associated with them is grouping of information, property sets, and then there's attributes. And one of the issues we have on attributes is they require uses of particular measurements of units, data types, etc. So when we're passing that information, we know that it's in the correct format for us to get out. So we need to know the context of use of that information, and we need to know the relevance of that. So that's all included within the way that is defined on that. But to make sure that the key on this is making sure that there's provenance. So on the product data, it's all being dealt with by the Construction Products Association. So they're what we call the lead authority. They create relevant authorities, so the big trade associations, grouping, etc., which is they're the guys who basically have the technical knowledge about the information related to their particular product range. And then there's a whole series of roles defined for people who can define these data standards, who are going to check them, review them, approve them. You might actually notice that's actually a crap process, but but in terms of information exchange, that's where we're trying to get to, and it's all down to people in terms of how we deal with this stuff. And there's a workflow to show that the things happen, and if we get issues, then stuff needs to go back. But the trade associations and technical experts are dealing with all of that. So quick overview of the tool. So the focus at the moment is in product data. So lots of stuff there. You can even go to the templates there, look at it that way, or you can just click on the particular data groups that you're particularly looking for. At the moment, the idea is this will be available to everybody. It'll be a web API to link to authoring tools and other solutions, manufacturers, etc., to allow you to get information. So when you start looking at a particular template, then actually you can get down to the particular requirements of that. You can look at the status of things. You can then start getting down to the property sets and the attributes associated with particular objects, and also see which objects they're mapped to. So there's quite a lot of work happened in terms of defining the basic schemas that are required for industry on that. So basically these libraries will provide the core building blocks through Lexicon. The relevant authorities are being set up at the moment, and they're starting to do some work. So people like SIBSI have already been creating their product data templates, but we're just asking them to actually add a few extra bits of information so we can actually start to standardise these things. As I said, there's different types of objects that we're looking at. The focus at the moment is on construction products, but we're even talking about built assets, grouping, even to smart city type scenarios. There's going to be lots of different information requirements that we need to standardise on across industry if we're going to start to make this thing work. But it's not just the UK. France have PPBIM, there's other schemes going over for Europe and also across the world on that. So the Building Smart Data Dictionary is a way that we can start mapping these particular locale versions together to try and drive this stuff. So hopefully at some point we get to this scenario where the whole, the geospatial, the graphical, the city, the BIM, people, social data, is all tied in with security, so we can exchange information to those that we need to exchange information with in a standardized format that people can use, so we can actually get better decision making. And the focus of this for BIM has been design and construction, and everybody thinks that that's how BIM is going to resolve that problem. Actually, BIM is just a tiny bit. It's when we start to getting into business outcomes with good information, that is the stuff that's actually going to drive the whole way our built environment works. So, thank you very much for listening. Some of the challenges that we're trying to get on with and drive. And any questions? Thank you very much.